Okay, so today we're going to learn how to find molarity, and we're going to be looking at Interactive Notebook page 4. So if you'll turn to Interactive Notebook page 4 and you'll turn to your molarity calculations worksheet, it should look like this. And there's 9 problems on the front. Today we're going to be looking at problems 2, 4, and 7. Okay, so in order to find molarity, we first have to know what molarity is. Molarity is a measure of concentration. So it tells us how much solute is in a solution. We use capital M to represent molarity, and we know that it's moles of solute divided by liters of solution. And this is our equation. Now we also know that we can put this into a T box that helps us manipulate the equation better. Capital M for molarity, or concentration, and then it's moles and L for liters. And we must be in these units in order to be able to use this. Now, we've learned that when they are side by side, we multiply, and at their top and bottom, we divide. And all we have to do is cover up the thing that we're looking for to figure out our equation. We know from our worksheet, the instructions on our worksheet say to calculate the molarities of the following solutions. So we're going to be looking for molarity, or capital M. Okay, so let's look at number 2. To calculate the molarity, well, I know that capital M is moles and liters. In order to find molarity, I cover up molarity and I need to use moles divided by liters. So I know that my equation will be moles divided by liters. So I look back at my problem. When I look at my problem, I notice that I have 1.2 moles of calcium carbonate and 1.22 liters of solution. So 1.2 moles goes on top and 1.22 liters goes on the bottom. So now I just put this into my calculator and I take 1.2 divided by 1.22 and I get 0.98. So 0.98, I make sure to include my unit, which is a capital M for molarity. And I was able to put moles over liters in order to get my answer. So now let's look at number 4. With number 4, in order to calculate the molarity, again, I say molarity equals moles and liters. Looking for molarity, that means my formula is going to be moles over liters. Well, I have 0.75 moles of lithium fluoride and 65 milliliters of solution. So I know that I'm going to be able to put 0.75 moles on top, but I have a problem with 65 milliliters of solution. Well, I know a conversion, and I know that I can divide milliliters by 1,000, and that'll give me liters. So 65 divided by 1,000 gives me 0.065 liters. So now I'm able to plug 0.065 liters in, and so I put into my calculator 0.75 divided by 0.065, and I get 11.5 capital M molarity as my answer. Now, in comparing these two different solutions, 0.98 would be a low molarity. It would mean that it was not very concentrated. 11.5 capital M molarity would be a very high concentration. So this solution is more concentrated than this solution. We would say that 11.5 was concentrated, but 0.98 was dilute in comparing their concentrations. Okay, so let's look at the most difficult problem from this problem set, and it says number 7. Number 7 is 98 grams of sodium hydroxide in 2.2 liters of solution. Okay, so I go back to my formula since I'm finding molarity. Molarity is moles divided by liters. In order to find molarity, moles divided by liters. And so I have to look at my problem. Well, I have 98 grams of sodium hydroxide. Grams poses a problem. I'm going to have to turn grams into moles. So I'm going to take 98 grams, but I need to know the formula. Well, in order to find the formula, I'm going to have to check the charges. So I look up sodium. Sodium is in the first column, so it is a +1 charge. And hydroxide is on the back of my periodic table. It is a polyatomic ion, and it's OH -1. Well, +1 and -1 cancel out, so my formula is just NaOH. So I have 98 grams of NaOH. Since grams of NaOH is on top, grams of NaOH comes to the bottom, and that's going to be 2 moles. Well, I know that 1 mole is going to equal the mass on the periodic table. So Na is 22.99 plus O, which is 15.99, plus H, which is 1.007. I add all of those together and I get 39.9, or 40 basically. And so I have to divide that. 98 divided by 39.9 gives me 2.46 moles of NaOH. So now I'm able to put 2.46 up here with moles. And then I have 2 liters. I don't have to do any conversion for that. Divided by 2.2 liters. So I type that into my calculator. 2.46 divided by 2.2 gives me 1.12 capital M for molarity. So that's how we find molarity, which is a measure of concentration, and we always make sure that our units are in moles and liters. In the first problem, they were in moles and liters, so I divided them and got my answer. In the second problem, they were in moles and milliliters. I had to turn milliliters into liters by dividing by 1,000, and I got the answer of 11.5 capital M molarity. And then the last problem, number 7, I was given grams. I couldn't put grams into the formula until I had turned it into moles, so I divided by its molar mass on the periodic table to get moles and then plugged it into my formula. This is how you calculate molarity.